Today on the Why of Math, we're going to be discussing why the continuous compounding formula works and what it means to be compounding continuously. Now, right here we have the equation for compound interest over a certain number of periods per year. 1 plus r over n to the n power. Now, if we take the limit as n goes to infinity and distribute the exponent according to the normal distribution rules, it gives us 1 plus n choose 1 times r over n plus n choose 2 times r over n squared plus n choose 3 times r over n cubed, and so on. Evaluating n choose 1, 2, 3 gives us 1 plus n times r over n plus n times n minus 1 over 2 times r over n squared plus n times n minus 1 times n minus 2 over 6 times r over n cubed, and so on. If we take the limit as n goes to infinity of n minus anything over n, that's going to tend to 1. So evaluating that limit, we get 1 plus r squared over 2 plus r cubed over 6 plus r to the 4th over 4 factorial plus r to the 5th over 5 factorial, and so on. But this is just the Taylor series for e to the r power. Then raising this value to the t power gives us e to the r to the t, which is just e to the rt power. And what does it mean to be compounding instantaneously? Well, it just means taking the derivative of e to the rt. Continuous compounding is a situation where the function times the rate of interest is the derivative of the function. And that works out to y equals c times e to the rt, with c being your initial investment. That's our description of continuous compounding. Remember to like, share, and subscribe, and leave your questions in the comments section. Thank you.